Welcome to the Unofficial Ignition Podcast. I am Mathias, and today I'm honored to welcome the one and only Kevin McClusky from Inductive Automation. Kevin, please introduce yourself.
Oh, Mathias, thank you. It's so good to be here. So my name's Kevin McClusky. I'm an official Inductive Automation employee. So I appreciated the little bit of irony that I'm on the unofficial Ignition podcast. My name's Kevin McClusky. I'm Chief Technical Architect here at Inductive Automation, and I've been with the company about 13. It's going to be 14 years this year. So. It's been a wild ride. It's been a lot of fun. I love the technical bits and bolts and all the rest of that. So yeah, it's great to be here. Thanks for having me.
Perfect. 13 years, almost 14 years. That's almost from the beginning then, isn't it?
Yeah, we're actually going into our 20th year in 2023. So it's in Ignition, Inductive Automation 20. But I've been around since the beginning of Ignition, which was 2010. Before we actually even released the current product that everybody knows and loves.
Perfect. Cool. All right. So today's topic is the concept of best practices in Ignition, and I thought we could have a discussion about that. So my first question would be, when it goes into scripting, that's some of the parts we're spending a lot of time on. And we have this scripting library, and I was wondering, when do you use the scripting library, and when do you actually just use your script directly in the components? And is there any pros and cons on that?
Sure. And that's a great question. You know, a lot of folks run into that, and you can certainly do scripting directly inside the screens. If your vision, it's inside the windows. If your perspective, it's inside the views. Or you can put it inside the scripting library, which, as you know, is a central place that you can do scripting from and have that accessible across your whole project. There's no one answer, but my general approach is that if you have a script that you think is going to be useful in more than one spot, if you find something that you're going to have 2 or 3 different screens that are using the same script, having that inside the script library, it can make a lot of sense. Or if you have a function that you're using that's part of a bigger script and you think that function could be useful somewhere else, having that in the script library can make a lot of sense. If you have individual screens where the screens have really specific things that they're doing, if you have a screen and you press a button, it takes variables from 3 or 4 different settings, somebody's just set inside that screen itself, and it pulls in maybe 3 or 4 tag values and does some sort of calculation, presents that to the user, and then they press a button and it does some other transformation and sends it over. Most likely that script belongs on that screen as opposed to belonging inside the script library, because you're normally, if you have something that's really tied to a screen like that, you're not really going to want to try to invoke that from somewhere else, because that UI element is really important for it to actually be useful. There are a couple of exceptions to that rule. There's been a couple of customers who've gone through and put every single script inside their script library. And the only real advantage of that is that it does give you all of your stuff in one spot. And if you want to have somebody who is reviewing all of your scripts for code practices, or making sure that the overall style matches your company's style, that the variable names are good, that there's comments in the right places. So if you're doing code reviews on a regular basis, which isn't a bad idea, that can give you one central spot to have all of those. So I've seen a few folks do that where they put absolutely everything inside that script library, but it is more common to have the shared things inside the script library that you're going to use across multiple different places. And then you have in the specific screens where you have specific scripts that are only for those screens to have them there. We do the same type of thing inside some of the Exchange resources that we create as well, where if you have multiple different windows or views inside these Exchange resources that are all using the same scripts, we might have those inside the script library part of the Exchange resource. If it's just inside those screens, then we'll often have the scripts inside those screens. And then when you copy those screens around or copy them to a new project, you don't have to worry about copying things from the script library as well at the same time. You can just grab those specific screens. It's all self-contained. It's all right there, everything that you need, and then it gets over to wherever it's going.
Okay. So basically, what you're saying, it's sort of a balance. There's pros on the scripting library, and there's also cons on that as well. So it's always
Yeah.
based on the use case, but actually, all right.
Yeah. Yeah.
So now you mentioned that with the if you can copy it over to another project. There was also one of my thoughts here was about the project inheritance that you have introduced a few versions back now.
Yeah.
What is actually what is actually inherited when you are moving around in there? Because I think sometimes it's hard to figure out like what is actually inherited in this project. Could you give us a few words on that as well?
Sure. Yeah. Project inheritance is, in my opinion, if you're doing advanced projects, it's one of the most useful features that you can have if you're doing an enterprise type of deployment, something where you're going to multiple sites or multiple buildings in a single site. You have multiple ignition gateways. Because what it lets you do, you have, for those who are listening who aren't familiar with the concept, basically you have a project. That project has some resources inside it, and then other projects can use that as a parent project. And when they have that as a parent project, it inherits resources. So to answer your question directly, the resources that are inherited are almost everything inside that parent project. So the parent project has the script library that's going to be inherited. If that parent project has windows and views and transaction groups and pretty much anything that shows up as a project resource, that is going to be inherited into whatever that child project is. It's going to be accessible. It's going to be viewable inside the designer. You'll be able to see it listed out, all the resources that are in that parent project. The couple of things that don't necessarily transfer over are some of the project properties. And it's kind of, you got to look at the documentation if you want to see which project properties might transfer over from a parent to a child. But those project properties, that's in the designer. If you go up to the top and you go to project properties, you're going to see the settings for things like security settings and stuff like that. And so often that is just, and the child has that set up rather than inheriting all of those from the parent. But yeah, any scripts, any windows, any views, any transaction groups, any web dev endpoints, any pretty much anything that you see in the designer on that left-hand side, you're going to get inheritance with.
And then you also have the option to actually override some of the things that you have inherited from a project. When to do
Yeah.
that and how to actually manage that, because I could imagine that you end up in a situation where it's hard to figure out like, so was this resource actually something I added myself, or was it something I actually
Sure.
overrode? So how do you keep
Yeah,
track of
yeah,
that?
yeah. Yeah, we did change our iconography. I'm saying that wrong, but we changed our icons for the resources a little while back, that where it indicates a bit more clearly now if you've overridden something, if you're just taking a look at through the project tree. But the general question there, if you create a project that you're inheriting from, generally that project's going to have project resources that are specific types that you want. So script library is a great example. These would be scripts that you want to make accessible across all of your different projects, and possibly scripts that are available across the entire enterprise. So there are folks who have 70 different plants that all have ignition installations, and they've got one global project that has all of these script functions that they write once. It works great for their enterprise, and then they deploy it everywhere. They send it out over enterprise administration module, press the button, it sends out the global project. Everything inherits from that global project. And then, you've updated all of your children project, all your projects across the entire world. At that point, the whole enterprise is just single button press, and then also just inherited resources. Normally, the time that folks do overwrite those resources is when I've seen it the most commonly on screens. So if they've created windows or views and they have a standard project that might be in some global project, inherited project. And so they've got, maybe a standard tank control project, and that tank control project has, it takes a look at the tags and it shows all the tanks, and then people have buttons that they can press and do these things. And that's standard across, if it's an enterprise that has 70 sites, maybe it's standard across 69 of those sites. So they push it out, everybody uses it. that 70th site has maybe tank sensors that are different. Maybe it doesn't have level sensors. Maybe it has a load cell that works differently that only shows between 0 and 60%, and so you don't have a view between 60 and 100%, and so it doesn't really make sense to use that same project that you have for everywhere else. But you might not want to lose the menus. You might not want to lose the overall structure of that project. It might just be that tank display that is different for this specific location. In that case, you would override this tank display. You do a child project, right? And from the global, and you override that one tank display screen, that window. And then when you launch it there, it's using its own local, updated tank display screen there, whereas it has all the same stuff as the rest for the global project. So that's pretty common. The overriding of script functions inside the script library is not very common, and I wouldn't suggest doing that for the reason that if you do that, it can become really hard to maintain. So just like what your question was alluding to, if you're making a change to that global project, all these script functions that you expect everybody to be using, and then you get over here and it hasn't updated this project, because they have an override, that doesn't give you the behavior that you want, right? So I wouldn't really override anything that's intended to be a global script resource, but those individual windows and views can be a good thing to override. And of course, projects can have their own script resources. Just because you're inheriting doesn't mean your project can't have its own script resources side by side, but I generally wouldn't do those as overrides.
So do you then normally set this, you have this option to actually select if a resource can be overridden in a child project? Do you generally use that to make sure that nobody accidentally overrides something then?
It's not a bad idea. Yeah, absolutely. That's part of the idea there. Yep.
Yeah. Okay. Cool. Then what about UDTs? Now we talked a little bit about inheritance there for the projects, but then when we go to UDTs, you also have this. You can different ways of building UDTs. We've seen that sometimes you are using a UDT where you have a child-parent structure there, or otherwise you have maybe UDTs that are more resembling how your actual component looks like, or something like that. What are the pros and cons there? What have you seen some other ways to do that?
Sure. Yeah, generally what we'll advocate for when we're talking to folks from the sales engineering division at Inductive Automation anyway, is to have it represent things in a way that's going to be scalable and going to work across different areas, different locations, different facilities. And even if folks are just doing an installation for single facility, Ignition almost always grows. And so a first installation will go in and they say, this is the whole scope of the project. And then 2 years later, they say, this is working great. We're really happy with it. We want to send it out to these other 3 or 5 or 10 buildings or locations. And when you get to that point, if you've been thinking from the get-go about how to make this scalable when they do want to move to more locations, it's going to save everybody a lot of work, a lot of time, a lot of effort. So thinking about UDTs in that same way, if you're creating a pump UDT, what can you boil that down to? How simple are pumps across the entire organization? And then how do you create different types of pumps? So generally what we'll say is go in, figure out what the physical is, figure out what the standard data model is going to be for the very basic version of this for the specific company that you're working with. And every company might look a little bit different. Some of them are somewhat standardized, but it's uncommon, right? So most companies have come up with their own PLC standard, their own tag standard for these things. And so pumps are always going to have maybe a speed, or maybe an RPM, or maybe a flow rate. Probably not a flow rate, because some pumps you might not have sensors for that type of thing, but you get the idea. So figure out what the minimum set of tags is. Maybe every single one has an HOA. They always do handoff auto, some sort of control on their pumps. So in any case, that figure out what that is, create a UDT that is that, and then for the specific types of pump, create one that has the flow rate and maybe it's a peristaltic pump and you actually have an volume that is going through. So have a volume tag for a peristaltic pump. Create one that's a peristaltic pump, it's that name, inherits from pump, and then has the additional tags inside there. And then one of the really nice things that you get is when you drag that out to the screen, you're going to get the ability to use any templates, any views that you've set up for that data type for both peristaltic pumps and for pumps in general. So if you just want to display it like a pump, right? You build a display for any pump that's a generic pump display. You could drop that on any screen that you want as you're building it out. And all of your pumps will act like a pump. If you're comparing them side by side, you can, get a little fancy and put them in a big table if you wanted to. You can have template repeaters or view repeaters that are there. You can do a lot of cool stuff if you've got it set up where your inheritance model is right there, and it's going back to the base types of these. And then you can also create different iterations at the top end of that. So if you've got a peristaltic pump, there are different manufacturers for peristaltic pumps. There are different types of peristaltic pumps. There's different types of metering that you might have. And so you could branch that out as well and create, a peristaltic pump from vendor X, and then have that pointed back at the peristaltic pump as the parent. And then that's pointed back to the pump as the parent. So you get this tree of inheritance there. Often that makes a lot more sense than doing it based on screen design. Screen design can be nice in terms of just binding things through, but it also is somewhat limited in terms of if you're doing more than just this one screen with these things. Later on somebody wants to create a screen that is designed differently, it looks differently, or they're using vision and now they want to use perspective and build it out using some other features that are in perspective, or vice versa, right? If you have your UDTs based on your screen design, then that limits it a bit more, or you've got to go through some hoops to get it to show up exactly how you want to. Whereas if you have it based on the physical, and then based on potentially the organization's structure for all of that, then it's going to give you something that makes it easier to continue to innovate and continue to iterate on that design going forward, or even toss the initial design and come up with a brand new awesome design that somebody else comes in and says, oh, what if we did this, right? You want to be able to say yes to that. You want to be able to just go in and create cool stuff.
Yeah, so basically you suggest that you keep your UDTs more based on the components and what type of components you have, rather than the visuals you have on screen, because then you sort of you can always change the visuals out to, as you said, vision or perspective, or make a new edition of it if somebody else wants it to look differently, and so on.
Right.
So how do you do about so now let's say we build the UDTs in this text, in this tree structure you mentioned there, where we have one pump that is then, and then the peristaltic pump that is actually based on the standard pump, so to speak. How do you do that with the tags in the PLCs? Is there anything where you say, well, obviously it would be best if that is structured in a way, but if that is not the case, what do you then do? Is there anything there you can do on the UDT side?
Yeah. So there's that's a good question. So if they're structured the same in the PLC, then great. You can just bind those or set those up, point them in the appropriate area with the appropriate OPC paths. If they're not structured in the same way, but there's some sort of a pattern, often you can use the parameters in the UDTs to say, this is my path. This is my path to this. This is my path to this, or my hierarchy to this inside the PLC. So an OPC structure to get to flow, right? A flow folder, let's say, call it whatever you want, right? And then that might give you the flow, where to find the flow tag that's going to be sitting under there. And then you can bind to those parameters internally inside the UDT. If you have things, I've seen a number of companies, after they get a bit more mature with some of these things, to actually set up inside their PLCs some standard data structures. And so their company as they're going through, they realize that standardization actually is a good thing, and they've never had standardization on the PLC side before. They say, okay, let's start working toward that. And so they'll create some structures that they can load into their ladder logic. So when they're creating a new project going forward, it'll automatically have the right things there, and it'll tie to their data model that they're setting these UDTs up with. And that can become the basis for their whole data model for their organization. So you can compare apples to apples across everywhere. That's a journey to get there, of course. And PLCs are it almost always starts out where the PLCs are all different from each other in terms of what those tag structures are. And so you've got to have some sort of mapping like that. But yeah, those parameters are generally the way to do some of that mapping. And you might even need to create different peristaltic pump types that inherit that are for different PLC structures, so that you can have it somewhat automatic there. You put in the PLC name, you've got the paths already built in there for where those tags are going to be found. There could be different scaling for different PLCs, like one could be scaled 1 to 10 and one could be scaled 1 to 100. Integers that are getting scaled down to floats. And so that scaling mode might need to be different. And so if you have different UDTs, you can apply different scaling to those different UDTs rather than needing to go through some other magic and have expression tags and some other, like it becomes pretty difficult going the other way. But if you've got different types based on the different structures that are inside there, that can be a nice way to map all of that stuff with relatively low effort after you do it once. So you get it set up once, and then you've got that structure. And then when you roll out additional ones, it's pretty easy.
So you touched a little bit on that subject, actually. So when we have these smaller pump UDTs, is sometimes we see that people are building like huge UDT structures there, where with a lot of things in there. Is that a way to go, or do you prefer to have it more separate and smaller chunks, basically, so it's easier to maintain, maybe?
Yeah. There's a balance. In my opinion, it does depend on the industry somewhat. So sometimes you have bigger pieces of equipment that have some pumps embedded in them, but you might want to just treat that as a cell on a line, a big thing that has a bunch of tags underneath. And I think in that case, you don't necessarily need to break out the pumps individually if you're never going to look at them individually. If you don't care what that pump is doing, you only care what the big piece of equipment's doing, then it's probably fine to not have that separated out. If, however, that pump is an integral piece of it, you might control the pump individually, but you do have this big set of things. Often what I'll see folks do, and what I often advocate for, is having a big UDT maybe that represents this cell on the line, but that can have pumps, actual UDT instances that are pumps inside it. And so you can have your pump UDT, and then you can have this big line cell UDT that has pumps that are sitting right here, pump 1, pump 2, pump 3, that are pump UDT instances as well. So those instances, UDT instances inside UDT instances, is one of the more powerful things that you can do. And we built that directly in to make sure that you can use objects pretty much across the board, however you build things out.
Is there any limit to that, like how deep you actually can nest your UDTs in that way?
No artificial limits. Nothing that we've put into the software. And if you are running Ignition 7.9, which side note, please don't run Ignition 7.9 anymore. It's not supported from a security standpoint. It's not supported from an update standpoint. Our tech support will still talk to you for the next couple of years, but it's end of life when it comes to updates. But if you are running 7.9, yes, there could be some performance issues when you have certain levels or hierarchies of UDTs, especially if you're making some edits to them. The way that we had the edit logic, it was cascading in a certain way that if you have 500,000 tags, it might be take a long time for an edit to actually take effect. With Ignition 8, we redid all of that. So all of that is loosely coupled, and it is intended to be very performant. And with 500,000 tags, editing a UDT is almost instantaneous when you hit OK, when you're making changes, depending on how many instances that you have. But it's night and day compared to what it was before. So no artificial limits in place. If your hardware can handle the load, then it should be about the same level of a computing power required as if it was individual tags that were structured in that same way.
All right, cool. So best practice when it comes to transaction groups, is there anything there? So now we touched a little bit on the tags and the and other stuff there. So how about transaction groups? Is there any best practices there?
Yeah. Transaction groups are something that we started out with as a company. That was actually, even before Ignition, we had a product called Factory SQL. That was our very first product, and it was transaction groups. It was what became SQL Bridge later on. And so transaction groups are more or less the Swiss Army knife of data movement when it comes to how it comes into databases, how it can be pulled back out of databases. If you're not doing the tag historian, or even if you are doing the tag historian, transaction groups can do a whole slew of things. And I think a lot of folks don't realize how versatile they are. But there's a couple of things that are really common. One is event-based logging. So whereas the tag historian is real-time based logging, it's always going to keep a log of everything that's been going. Transaction groups are really good for logging events. So when there's a recipe that is starting, when there is a valve that's closing and it indicates that it completes the process, and you want to capture these 20 values all at the same time, and they're one row. Transaction groups are fantastic for that type of thing. You can easily set up a trigger and have it put that into the database. And if I'm thinking about a project, it depends on what's happening in the project where transaction groups make sense. But one place is that event-based logging. So if you have batch records, if you have any sort of records of events that are happening that you want to capture some data around, it's really great for that. Second place would be if you want to have recipes and you don't have this Episoft recipe changeover module, for example, or you're not using anything else beyond that. Transaction groups can be fantastic for recipes because it's real easy to set them up, point them at a database table that has recipe information, and then have them trigger based on a change. And that change can come from a HMI somewhere else, that can come from inside Ignition. So when a user selects a different recipe, you can just synchronize that down from the database down to the PLC. One other thing that's really useful in transaction groups that I think a lot of folks don't realize is you can synchronize memory between different PLCs. And that synchronization isn't just PLCs in the same brand, where often with PLCs in the same brand, you can do shared memory between those PLCs. They've got different names for it for the different PLC brands, but there's a lot of different ways to basically share tags between PLCs of the same brand. If you have different brands, you're not sharing tags between those PLCs. They're not really communicating with each other. Like an Allen Bradley is not going to talk to a Siemens and share its memory. That's not how it works. But if you use transaction groups, you can do that really easily. You just set up two groups, you synchronize them to a database table, and set up the update mode appropriately, and then this set of tags that you're pointing at in the Allen Bradley PLC is going to now always match the set of tags that is sitting over in the Siemens PLC. So it creates basically a shared memory space, and you can have that shared memory space not just across two PLCs, but you could have it across 5, you could have it across 20, right? It becomes something that this is a little bit of a traffic orchestrator in the middle and central repository for some of this data. So that could be a cool thing that you can do there too. You of course can log event-based or time-based data as well, kind of like the tag historian does. It has zero compression basically when you do it through transaction groups. And all of these things, as I'm designing a project, I'm thinking through, am I doing these things? If I'm ever going to have a log somewhere that I want to take a look at later, I'm probably going to use a transaction group to populate that log table, because that's events, right? A log table is almost always events. If I have something that is going to be communication between PLCs, I'm going to think about, well, does it make sense to have Ignition bridge this gap, or am I going to try to run through some other hoops here? If I'm doing a tag change script on a tag itself, and I'm thinking about, how do I actually take this? Does this make sense as a tag change script? The answer is going to be, it's going to depend on what I'm doing with that tag change script. So if I'm doing something where I'm just logging this information to a database, I probably should use a transaction group. It's going to be easy to maintain. It runs in a separate thread pool inside Ignition. Other folks who open up the designer will be able to see it and find it easily. If they're taking a look at that table name, they can go into the transaction groups, find out which one's going to it. If they want to add to that table, they can just drag another tag in. So it's a lot more maintainable if I do it in a transaction group that way. But if I'm doing a tag change script and it's writing to a RESTful web service that's somewhere else, and I want to communicate across multiple different things, then I'm going to definitely keep it as a tag change script. That's the type of thing that scripts are really good at.
Cool. So basically, the transaction group is that's powerful stuff when you know to use it in the right way.
That's right. That's right.
Cool. Yeah. So I think that was pretty much all I had for today. I think I would thank you very much for sharing all your insights on this, and I'm sure there's a lot more to come for. Is there anything you would like to say here as a wrap up?
Sure. Yeah. So I'm excited about the next piece that we have coming with Ignition, and I'm sure a number of folks have seen this at this point or aware of it, attended our conference, seen a little bit of press about it. But right around the corner, and actually, I'm about to go into another meeting as soon as we're done here, and the meeting is on Ignition Cloud. So we're working out how we're going to get some of the splash out there, have our team fully trained on being able to support it when it's released. But Ignition Cloud is this new product that we're releasing. It's basically Ignition running in the cloud, and you can run Ignition in the cloud right now, but it's going to have some built-in features that are cloud-based features. So we're adding a few cloud technologies that are going to be part of this. And then it's also licensed with a cloud type of consumption model where basically you can spin it up. If you spin it up for an hour, you pay for an hour. If you spin it up for a day, you pay for a day, right? You don't have to buy a license up front. And when folks are thinking about spinning something up for a short period of time and bringing it back down, it enables a lot of cool things that folks might want to do, and also enables them in bigger infrastructures too, where you might want to have scale out architectures and you have an additional front end that you're going to have extra load over the weekend. So I'm going to spin up another server and then I'm just going to bring it back down. You don't have to worry about coming in and buying another license and then having that server sitting there idling, doing nothing most of the time, right? So so it's going to be a neat product. It's alongside all the rest of our products. If folks are running in the cloud already with Ignition, there's no need to change how they're doing it right now. But when folks are doing new installations that are going to be running in the cloud, it's going to be an additional option that folks have to choose from. And we're pretty excited about it. We're planning on launching on AWS and Azure. And then at some point in the future, we'll probably add support for Google Cloud Platform as well.
Perfect. We are definitely looking forward to it. That's for sure. Cool. Well, thank you very much, Kevin, for participating here today. And I know you have a tight schedule, so thank you very much, and see you around.
Yeah, absolutely. And thank you so much for having me. This has been a pleasure. I've watched a few of your other podcast, guests and some of your other things here, and you guys do a great job, and appreciate our partnership with you guys too. So thanks a lot. Take care.
Thank you.